Hey Algebros! Time to get into some of the tips and tricks when it comes to working with roots and radicals. Note that for simplicity, we're only going to be working with square roots. When we get to other things, it gets a little bit more complicated, but as a whole, when it comes to any kind of roots and radicals tricks, the rule of thumb is that we always need to have the same index. We're making it easy for ourselves as only exclusively working with square roots. So we always know that our index will be 2. All right? Some of these sort of fall more in the line of just like, a fact about roots and radicals. Like, for example, multiplying a non-radical number with a radical looks like this. So for example, let's put out some eggs real quick. If we had, say, 2 times the square root of 5, we can't move the 2 inside the radical. The 2 has to stay outside, so we write 2 right next to the radical 5. Kind of like a variable. Kind of like the radical 5 is a kind of variable here. Note, do not invite 2 into radical 5's party. It's not invited. What I mean by that is that you cannot bring a non-radical number inside the radical. All right? Further example, let's say we had 7 times the square root of 3. Similar case right here, 7, radical 3. Okay? That's nice and easy. That's just a notation thing that we need to keep in mind. Kind of following up on that, is that we can add or subtract roots with the same radicand. Recall the radicand is the inside number, like their variables. But we don't touch the radicands. So this can be also known as the addition-subtraction rule. So what this basically means is, you're still thinking about these radicals as if they are variables, okay? Kind of like in the same context as if we were to do it by variables, all right? So here, if I had, say, 3 radical 3. By the way, whenever I say radical 3, that's just short for saying squared, all right? The square root of. So when it comes to square roots, we can write them as either square root or radical when we read them, just so you guys know so we don't get lost. If I were to add that on to 5 radical 3, we note that we do have the same square root and the same radicand, so these are the same. So we are free to add these together in such a way that we just add on, oops, did not mean to do that, in such a way that we add on the outside numbers. So we add the outside numbers. And Algebros, if we have no outside number, what is it? It's just 1. No number means it's 1. So here would be 3 plus 5 times radical 3, which is just 8 radical 3. How about if we had something like negative 2 radical 5 plus radical 5? Well, if we identify the outside numbers, here I have radical 2. Sorry, not radical 2, negative 2. And out here, this is if it's 1 radical 5. So here is as if it's negative 2 plus 1, so it's negative radical 5. Note this negative is on the outside, not the inside. We'll talk more about that later. But let's move on to another one real quick. Let's see one with subtraction, actually. Let's see 10 radical 10 minus 15 radical 10. So again, we do the subtraction. In this case, it's 10 minus 15, so negative 5. And we slap on the radical 10 as if it were the variable. But could I do something like, say, radical 5 minus radical 3? No. They don't touch. So if I were to ask you to simplify an expression and you were left with something like this, then you just leave it as it is. Radical 5 minus radical 3 is technically the simplest form. All right? Let's not get this confused when we start talking about multiplying and dividing. Because when we multiply and divide, we can combine radicands with multiplication and division under the same root. Under the same root. Again, given that we have the same index, but that is something we are just implying going forward. We're just going to assume that we're dealing with it for these cases. So, for example, just as some very general non-numerical examples, if I had the square root of a times the square root of b, that can equal the square root of a times b, or the square root of a divided by the square root of b. That can be written as the square root of a over b. But the square root of a plus the square root of b is not the square root of a plus b, and the square root of a minus the square root of b is not the square root of a minus b. So, okay, for multiplication and division, no good for addition subtraction. Okay? That's basically the entire concept of this. Let's get a couple of examples real quick. These are going to be really like the heart of some of the examples we're going to be seeing going forward. So let's see some proper numerical examples. Let's say the square root of 5 times the square root of 7. That multiplication can easily give me the square root of 35, since 35 is 5 times 7. But radical 5 plus radical 7, no, can't simplify. Similar thing would go if I did the square root of 5 minus the square root of 7. Same thing here. However, the square root of 5 over the square root of 7, I can simplify that to the square root of 5 over 7. And if I want to write that as a decimal, I could do that too. Now, whenever it comes to multiplying numbers like this, things could get a little bit hairy, but we'll talk about that later. But for right now, I'd like to move on to the next rule, which I think is 4. Yeah, it's 4. All right, the next rule to talk about is more so just a notation sort of thing. So radicals are usually just fraction exponents. Some of you might have been wondering last time about what a case of fraction exponents would look like. This is it. For square roots, which is our focus here, something like, say, the square root of a would equal the square root of a to the power of 1/2. It's always 1/2 for square roots. So, for example, say the square root of 5 is just 5 to the power 1/2, or the square root of 9 is basically 9 to the power of 1/2. So on and so forth for any other radicand you might have. All right? Number 5 is a sort of consequence of that. So, consequently, square roots and a squared radicand cancel out. So let me show you the proof for that. Well, actually, let me show you what that result technically means. That means if you ever have the square root of some number squared, or the square root of a number also squared, that basically just equals that radicand. Why? Well, let me show you why. If we start off with, say, the square root of x squared, this also works if you go the other way. Isn't this basically, by rule number 4, just x squared, all to the power of 1/2? So this is by rule number 4 here. Then in the next rule, using the power rule, can't we multiply the 2 and the negative 2 as the exponents? The 2 and the negative 1/2 as exponents. So it becomes x to the power of 2 times 1/2. Then you multiply 2 times 1/2 and you get 1, which is just x to the 1, which is just x, which is what we want. Numerically, this manifests in such a way when you think of, say, I'm going to go back to 64 here, the square root of 64. Isn't 64 just 8 squared? Then by our logic, we could cancel out the squared and the radical, and then we're left with 8. This is an important concept of what we'll call simplifying radicands, which we'll do later. All right? Another sort of consequence which we've already kind of seen, but I kind of just want to restate it anyway. A square root times itself is the radicand, or the inside number. So for example, square root of 5 times the square root of 5. Even if we were to implement our rules for this, we would get the square root of 25. But we already know the square root of 25 is just 5. So there we go. Same thing will apply if we were dealing with the most general case of x, which would be x squared, leaves me with just x. I believe we're on rule number 6 right now, right? Yep. Rule number 6. While we can have sorry, I just want to double check something. While we can have negative powers, negative bases in powers, my bad. We cannot have negative radicands for square roots. I'm going to put in parentheses, not yet at least. Could we have negative radicands for other kind of roots that are not square roots? Yes. But can we have them right now? Not quite. Not for squares, and at least not without introducing imaginary numbers, which is an entire other ball of yarn, which we'll come to later. All right? Before we go, I just want to give you your U-try, which is going to be some cases where you simplify expressions. I'm only going to give you 3 this time. So the first one I'm going to give you is the square root of 7 times the square root of 6 times the square root of 5. Negative 2, radical 2, plus radical 2, plus radical 2 will equal what? And finally 3. I'm going to give you the square root of 256 equals what? All right. That'll do it for right here, and I will see you guys in the next one. Take care.